Okay, so today we are doing implicit differentiation. So this is different than what we've been doing previously because when we've been like differentiating things, we've been doing it like y is equal to x squared plus 3. We've been differentiating y with respect to x, right? Like the dy over dx plus 2x, right? But as what we're going to be doing with implicit differentiation, we're going to be differentiating not with respect to x, but we can like differentiate everything within these functions, okay? So we have differentiated functions in the form y is equal to f of x. These are called an explicit function because y is written as a function of x. Okay, y is equal to x squared plus 2x plus 1. So if we were to take the derivative of this, it would be 2x plus 2, right? But in some cases, we're not going to have like an explicit function. We're going to be given like different functions, right? So these are called implicit functions. And this is because y is not written as an explicit function of x. X and y are related in one equation, okay? So we'll see some of these, like some of these formulas you'll see like might look familiar to those of in a circle or an ellipse, right? And we will get into that as well. Okay, so.
Wait, so instead of dy over dx, it would be dy over circle? Like, what would it be on the bottom?
Oh, like after we differentiate them?
Yeah.
Okay, so we will get into that later on, okay?
Okay.
But it like right off the hop, so when we like differentiate x squared, we're doing that with respect to x, right? So that will be 2x, right? But we can also differentiate y now. Okay, so when we do that, we're differentiating x with respect to x still, right? So that's actually going to cancel still. Okay. Oh, yeah, go ahead.
No, I was just like.
Okay, good. But if we want to like differentiate a function with y in it, we're still going to be doing it with respect to x, right? But when we do that, it'll be 2y multiplied by dy over dx or y prime. Okay, so like any time that we differentiate something with y in it, we have to include differentiation of y with respect to x in as we solve it. Okay, we don't have to with the x's because they will just cancel out, but with the derivative of y with respect to x, those will not cancel out, so we have to include those. Okay, dy over dx, another way we could write that would be y prime. Okay, so sometimes you're going to see that as we go through this as well. Just know that the dy over dx and the y prime are the same thing. Okay. Okay, so we could rearrange these equations to get y is equal, like to have everything in terms of y, and I take the derivative explicitly. But like when we get more complicated functions like 2x squared plus 4y squared minus 6xy, it would be very difficult and if not impossible. Okay, so instead of differentiating explicitly, we are going to differentiate implicitly. So a better method is implicit differentiation. And this is where we will differentiate both sides of the equation with respect to x, and then we will solve the resulting equation for y prime, or for the derivative of y with respect to x. Okay, so anytime that we take the derivative of a y, we will have to include that y prime or the dy over dx after. Okay. Okay, so we're going to find the derivative of this using two strategies, implicit differentiation and explicitly. So let's just divide your paper in half right now. Okay, so we will do implicit over here and explicit over here. Okay, so implicitly, we are going to take the derivative of both sides with respect to x. Okay, so how will we write this? So we will just go, so the derivative of x squared plus y squared with respect to x is equal to the derivative of 5 with respect to x. Okay, remember our sum rule or our addition rule? We can split this up. So this will be the derivative of x squared with respect to x plus the derivative of y squared with respect to x is equal to the derivative of 5 with respect to x. Okay. Any questions so far? Pretty good. Okay. So now we can take the derivative of these, right? So derivative of x squared will be 2x. Okay. And then when we take the derivative of x, we're taking derivative of x with respect to x. And then we will also differentiate our y squared. So we will get 2y multiplied by dy over dx. Okay. And that is going to equal the derivative of a constant is just going to be 0, right? So our dx over dx will cancel. Okay, and then we will be left with 2x plus 2y multiplied by y prime is equal to 0. Okay, so remember y prime and dy over dx, they're similar. Okay, so now we're just going to isolate for y prime. So we'll subtract 2x from both sides and divide by 2y. So then we'll get y prime is equal to negative 2x over 2y. And we can simplify that to be negative x over y. Okay, so that is implicit differentiation. So hardest thing there is just remembering to put in our dy over dx or our y prime when we differentiate a y. Okay, still dividing our page in half because now we're going to do it explicitly. So when we do it explicitly, things are going to be written in terms of x, right? So x squared plus y squared is equal to 5. So I subtract, well, let's just start here. So x squared plus y squared is equal to 5. We want to isolate for y here. We'll subtract x squared from both sides. And then we can take the square root of that. So y is equal to plus minus the square root of, what did we have? 5 minus x squared. Okay, no, just the way that I did it, I kind of did that in a bunch, but remember it was x squared plus y. Yeah, so I subtracted x squared first, and then I took the square root of that. Yeah, good comment though, okay? And so we need to solve two cases for this. So one will be the positive side and one is going to be the negative side, kind of like what we did in our pre-calc unit, right? Fun. So let's do the positive one first. So y is equal to the root of 5 minus x squared. We could rewrite this, right? The exponent on that would be 1/2. Okay, so now we can differentiate that. So y prime is equal to 1/2 multiplied by 5 minus x squared minus 1/2 multiplied by the derivative of what is inside the bracket. So you'll get negative 2x. Okay, we can simplify these two here. Yeah, so y prime is equal to 1/2 multiplied by negative 2x. That will give us, what are we doing here? So we have negative x on the top, and then we will have 5 minus x squared to the 1/2 on the bottom. Okay, so that is our positive case. And now I will do our negative case as well. So I'll put a box around this. Okay, so for a negative, so we had y is equal to the negative root of 5 minus x squared. So we can rewrite this as y is equal to negative. Okay, same thing. Now we can differentiate this. So y prime is equal to 1/2. Our negative is still there. Okay, and then we're gonna have 5 minus x squared, negative 1/2, multiplied by negative 2x again. Okay, so negative 1/2 multiplied by negative 2 will be positive x over, oh, that is a plus sign, sorry. Y is equal to x over 5 minus x squared to the 1/2. Okay, oh, and this is y prime, sorry. Okay, so we had implicitly differentiated. We found that y is equal to negative x over y. Okay, we didn't have x written in terms of y, but when we did that implicitly, we did. So we know that y is equal to the plus or minus square root of 5 minus x squared. So now that we know what y is, so y prime is equal to negative x over what y is, and we said y was plus minus square root of 5 minus x squared. And now we need to ask ourselves, are the products of this explicit differentiation the same as the products of implicit differentiation? Well, we had y prime is equal to negative x over the plus or minus square root of 5 minus x squared. And what did we have here? For our negative case, we had y prime is equal to x over 5 minus x squared to the 1/2. So that would be the positive case, right? And then we also have our negative case, right? Y prime is equal to negative x over 5 minus x squared to the 1/2. So therefore, y prime is equal to plus minus x over the square root of 5 minus x squared. And those are the same there. Good. Any questions so far?
So you just brought the two, the positive and negative together.
Yeah, this one here and this guy here. Yeah. Yeah, we can, when we can simplify our coefficients, we should as much as we can.
The same for the final answer.
Oh, for the exponent here?
No, like the final answer, you got
Yeah.
that by combining the positive and negative.
Oh, yes, 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 exactly. Thank you. Yeah, because when we differentiate the negative square root case, we got the positive, and then when we differentiate the positive case, we got the negative. So yeah, good question. Okay, so we're just gonna have a few examples of using implicit differentiation here. Okay, so let's use implicit differentiation to find the derivative of this function. So how do we want to start this? Well, let's do derivative of y squared over the derivative of x is equal to the derivative of x with respect to x. Okay, so after we have it set up like that, we can just go ahead and differentiate. Remember, anytime that we differentiate our y variable, we have to include the y prime beside it. So this will be 2y if we differentiate y squared multiplied by y prime. And then the derivative of x to the 1, this is going to be 1. And then you don't have to include this step in there because that's just going to cancel anyways. Okay, but I just wanted to show, like when we are differentiating for x, when we do it with respect to x, that just cancels out. Okay, so we can just kind of get rid of that. Now, our last step, we want to isolate for y prime. Okay, so I'll rewrite this. So 2y times y prime is equal to 1. So just to isolate for y prime, we'll divide by 2y. These cancel. And then we'll be left with y prime is equal to 1 over 2y. Excellent. Any questions there? Cool. Okay, so let's try to differentiate this one, please, implicitly, of course. Okay, so we're going to take the derivative of each term in this function. The derivative of 2y cubed will be 6y squared multiplied by y prime plus 2y multiplied by y prime minus 4x is equal to 0. Remember, when we differentiate x, we do not have to say we derived x with respect to x. We can just leave that out. And the derivative of a constant is just 0. Okay, so at this point here, was there a question? No, I was hearing ghosts. Okay, so let's add 4x. So remember, we want to isolate for y prime. That's like the objective of these types of questions. Okay, so let's get all of the y primes on one side of the equation, because that will allow us to factor it out. Okay, so if we add 4x to each side, those will cancel. And we'll be left with 6y squared y prime plus 2y plus y prime is equal to 4x. Yeah, excellent. So we will isolate for y prime here. So we will factor that out. So we get y prime, so then we'll just have 6y squared plus 2y equal to 4x. Now last step to isolate y prime, we'll just divide by 6y squared plus 2y. Okay. Those will cancel. And then we will be left with y prime all by itself, which is equal to 4x divided by 6y squared plus 2y. Yes, you could if you wanted to. I'm okay if you leave it like this. That's fine. Good question though, and good eye as well. Yeah, that's totally fine with me if you leave that there. Okay. We're good? Cool. Okay. Same kind of thing. So we'll take the derivative of each term. So derivative of y4 x, derivative of y cubed with respect to x is equal to the derivative of x to the 5. Okay, so we'll get 4y cubed y prime plus 3y squared y prime is equal to 5x to the 4 plus 1. The derivative of x is just 1. Okay, so what's next? What do we want to do? We have common terms over here. Yeah, factor out y prime. Yeah, that's a good idea. Okay, so y prime, if we factor that out, we'll just have 4y cubed plus 3y squared equal to 5x4 plus 1. Divide both sides. Now that we have y prime by itself, 5x to the 4 plus 1 over 4y cubed plus 3y squared. Excellent. Annabelle, is there anything that you want to factor out of this one? Is there something that we could factor out of it? What about our denominator? We'll leave the top alone. On the denominator, we could factor out y squared. That will give us 4y plus 3.
I thought everyone's fine, right?
Yeah, if you leave it here, that's fine by me. If you want to be one step higher, you could feel free to factor that, but I'm okay if it's at this point here. Okay. How do you feel about this stuff? Pretty good? It's not too bad. We are going to Well, I won't spoil the surprise. Okay. So this one, x squared over a squared plus y squared over b squared. Does anybody recall what shape this is a formula for? No? Maybe this will be for an ellipse. And we'll talk about that next slide. In a couple slides. Okay, so how do we differentiate this? It's kind of ugly, to be honest. But we can rewrite this. So first note I have to say here, A and B are constants. Okay, so we will not be differentiating those. Okay, so how can we rewrite this? So x squared over a squared, we can rewrite this as 1 over a squared multiplied by x squared plus 1 over b squared multiplied by y squared is equal to 1. Okay, so we will take the derivative of these, just the variables, so x and y, because a and b are constants, okay? So 1 over a squared multiplied by the derivative of x squared, x plus 1 over b squared multiplied by the derivative of y squared with respect to x is equal to, sorry, derivative of 1 here. Okay, so we will have 1 over a squared multiplied by 2x plus 1 over b squared multiplied by 2y divided by y prime. So if you don't like how these look now, we can make them look a little bit better. So you can say, now that we've differentiated them, we can kind of put them back into the fractional form so it's easier for us to work with. So that'll become 2x over a plus 2y y prime over b squared is equal to 0. Like we've been doing, let's isolate for y prime. So we can subtract 2x over a squared. Okay, so now we have 2y times y prime over b squared is equal to negative 2x over a squared. Okay, we can factor out a y prime on our left side here. So y prime, we'll have 2y over b squared is equal to negative 2x over a squared. Divide by our 2y over b squared. So that will cancel. And when we divide by a fraction, we're going to multiply this by the reciprocal of that. So y prime is equal to negative 2x over a squared multiplied by b squared over 2y. Okay, let me put the numerators together here. So y prime is equal to negative 2x b squared over a squared 2y. these twos can cancel. Then we'll be left with negative, and you can write this however you'd like, but negative b squared x over a squared y. Proper way to, you do the highest exponent first and then you work your way down, right? So this would be the absolute best answer. Okay. How are we feeling? Good? Yeah. Okay, we have time for one more problem for today. Okay, so before we even get going, what rule might we have to use for that one right there? One of our derivative rules. What are we doing to these two? We're multiplying them together. So when we multiply two things together, what is the answer? So when you add things, you get a sum. When you subtract things, you get a difference. Yeah, it's a product, right? So we're gonna have to use our product rule for this. Very good, Samson. Okay, so product rule is y prime is equal to u times v prime plus v times u prime, right? So this will be, we'll let our u is equal to x and our v is equal to the y. So u prime will just be 1. V prime will just be 1 multiplied. Remember, anytime that we differentiate y, we have to include our y prime in there. Okay, so our u prime will just, or that's our v, sorry. V prime is equal to y prime. Okay, so let's find our y prime of this. So u is going to be x. V prime is y prime plus v, which is y, multiplied by u prime, which is 1. Okay, so if we combine those, we'll just get x, y prime plus y. So what did we just do there? We found the derivative of xy there, okay? So like when we move to our next step, so remember we're gonna do derivative of 2x squared with respect to x plus the derivative of xy. We just did this part, okay? So we don't have to differentiate that again. We can just substitute in what our y prime is for the xy there, okay? Minus the derivative of y squared is equal to -7. Sorry, I ran out of space there. Okay, so the derivative of 2x squared is going to be 4x. And because we derived x, we don't have to include like the x prime. Okay, we already found the derivative of xy, which is right here, which is xy prime plus y. And then we are subtracting the derivative of y squared, so we'll have 2y y prime. And then the derivative of -7 is going to be 0. Okay, so let's get all of our terms that do not have y prime on the right side of the equals sign. So we'll subtract 4x and we'll subtract y, right? Y does not include y prime in there. So minus 4x minus y. Those will cancel. Then we will have x, y prime minus 2y, y prime, is equal to negative 4x minus y. Right? So we have y prime, we can factor out on this side, so we'll be left with x minus 2y is equal to negative 4x minus y. And let's divide. Now we have y prime by itself. So y prime is equal to negative 4x minus y over x minus 2y. And you could factor out that negative on the numerator there, but you don't have to. I'm okay with that. All right. So that is part A of implicit differentiation. Stay tuned for tomorrow where we will continue with this lesson.